It's B. Lokesh Saikma from CHC section. Today I am discussing about heap sort, subject name data structures. Introduction to heap sort. Heap sort is a comparison based sorting algorithm that uses a binary heap data structure. It is particularly efficient for large data sets and has a time complexity of O log n log n. It is a best time complexity. The algorithm can be implemented in both in place and non in place manners, making it versatile. Understanding heaps. A heap is a complete binary tree where each node satisfies the heap property. In a max heap, the value of each parent node is greater than or equal to its children. Conversely, in a minimum heap also, each parent is less than or equal to its children. Types of heaps. The two primary types of heaps are max heaps and minimum heaps. Maximum heaps are used in the heap sort to ensure the largest element is always at the root. Minimum heaps may be utilized in variations of sorting algorithms or periodic queues. This figure shows the array representation of minimum heap and maximum heap. Here, in minimum heap, the parent node is less than remaining all the elements. Here, in maximum heap, parent node is maximum among all the nodes. Heap sort algorithm overview. Heap sort consists of two main phases: building the heap and sorting the elements. The initial phase involves creating a max heap from the input data. The second phase repeatedly extracts the maximum element and rebuilds the heap. In this diagram, we can see how initial elements can be converted into maximum heap. Building the heap. The heap is built from an unsorted array by ensuring the heap property is maintained. This is done by starting from the last non-leaf node and performing shift down operations. The process continues until the entire array satisfies the max heap structure. This diagrammatic representation shows how we build the heap. Extracting elements. After building the maximum heap, the largest element is at the root of the heap. The root is swapped with the last element, reducing the heap size by 1. The heap property is then restored to shift down operation. Time complexity. Heap sort has a time complexity of O log n in the average and worst cases. The initial heap building takes O of n time, while each of the n extract operations takes O log n. This makes the heap sort efficient for large data sets compared to simpler algorithms like insertion sort. We can see in this diagram. Space complexity. Heap sort is an in-place sorting algorithm with a space complexity of O of 1. It requires a constant amount of additional space for the sorting process. This makes heap sort a space efficient option for sorting large arrays. Advantages of heap sort. Heap sort is not sensitive to the input data's initial order, maintaining consistent performance. It guarantees O of n log n time complexity for all cases, offering predictability. The in-place nature of the algorithm minimizes memory usage compared to other sorts like merge sort. In this diagram, we can see what is the advantages of heap sort. First one, time complexity. Second one, space complexity. Third one, stability. Fourth one, worst case performance. Fifth one, adaptive. It can adapt into various types of sorts. Disadvantages of heap sort. Heap sort is generally slower in practice compared to quick sort and merge sort due to constant factors. It is not a stable sort, meaning the relative order of equal elements may not be preserved. The implementation can be more complex than simpler algorithms, potentially increasing development time. Disadvantages of heap sort. The first one is not suitable for all small data sets. Second one, not a stable sorting algorithm. Third one, not an in-place sorting algorithm. Fourth one, worst case time complexity. Fifth one, not adaptive. Thank you, sir, for giving this opportunity.